Hello everyone, my name is Arnav Bhat from Class 8D, DPS Bangalore South. This is my submission for Stage 2 of Raman Awards. Now, have you ever wondered what happens in an RO water purifier? Well, the hint's in the name. RO stands for reverse osmosis, and it's when water molecules are forced from an area with a low concentration of water to an area with a higher concentration of water. Now, what's normal osmosis? Well, it's just the opposite. Water moves from an area with a higher concentration to an area with a lower concentration of water to stabilize it. Now, I found this experiment which shows this effect clearly. So, for this experiment, we will need a scale, weighing machine, some salt, some cups of water, and a few potato slices. So, for this experiment, I have filled each of these glasses with 100 ml of water, and when this one has pure water, the rest of these all have varying amounts of salt from 1 gram to 5 grams. Next, I will be taking these potato strips, each of them are 4 centimeters in length. I will place 3 of them in each of these glasses and measure them after 20 minutes. So these are the results. While the potatoes in the referenced video showed a marked difference within 20 minutes, my potatoes showed no measurable difference within that time. So I put them for another 20 minutes, for a total of 40 minutes. So as you can see, the potatoes in the pure water increased in size, in length, whereas the potatoes in salt water decreased a bit. So this is because in the pure water, the concentration of water molecules was higher outside than inside the potato. So the water molecules went into the potato. Whereas in the salt water, the concentration of water was higher in the potato than in the surrounding areas. So the water molecules flowed out of the potato. The same can be seen in the graph. So to the left of the red line is where the potato is hypotonic, meaning water is flowing into the potato. And on the other side, it's the opposite, hypertonic, where water is flowing out of the potato. Now at the exact point of the red line, that is where the potato is isotonic, which means it's at equilibrium with the surrounding water, and thus no water is flowing in or out. This is at approximately 1.5 grams per 100 ml of water. Also, I was wondering, why did the potatoes in that video increase in just 20 minutes, but mine took 40 minutes? Maybe it's because theirs were cylindrical whereas mine were cuboid. So I made a few cylindrical potato strips and did the same experiment, and my findings are that it does seem to influence the rate of osmosis. My theory is that the cells are distributed more evenly in a cylindrical shape, and thus the rate of osmosis increases slightly. I also made one interesting surprise discovery. So I had kept the cuboid potato strips out overnight by accident, and when I woke up, they had changed color in a very interesting way. While I had expected them to change color, they had kind of changed color in a spectrum. The ones exposed to higher levels of salinity had changed to a darker shade, whereas the ones exposed to less salt were lighter. So this made me think, do you think in certain settings they could be used to determine the salinity of water?